the properties of those tangents. Here are the state standards that we'll be looking at. A circle. Circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. Circle whose center is point P is called circle P. Symbolically, we'll write it with a little circle in front of the P, just like we do a triangle or an angle. A segment whose endpoints are the center and any point on the circle is a radius. So if it goes from the center to the circle, we call it a radius. A segment whose endpoints are both on the circle is called a chord. And a diameter is just a special chord. It's a chord that contains the center of the circle. So what we have here is a circle where the center is the point that is equidistant from all the other points. The radius goes from the center to the circle. A chord connects 2 points on the circle, and that diameter is a chord, but it's a special chord because it goes through the center of the circle. A secant is a line that intersects a circle in 2 points. So you can see that a secant contains a chord. The segment that just goes to the 2 points is the chord. The secant is the line that continues on out in both directions. A tangent is a line on a circle or in the plane of a circle that intersects the circle in exactly 1 point. And we call that place where it intersects the point of tangency. So remember, if a line hits a circle in 2 places, it's a secant. If it hits the circle in only 1 place, it is called a tangent. The tangent ray, BA, and the tangent segment, segment AB, are also called tangents. But generally when we say a tangent, we talk about the line, or we can talk about a tangent ray or a tangent segment. So let's look at some examples of what we'll be doing. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. Let me get a pen so I can mark what we're looking at. AC. Going from A to C, that simply connects the center to the circle, so that would be a radius. AB. It connects 2 points on the circle, but goes through the center, so that would be a diameter. Ray DE. Starting at D, continuing on through E, only hits the circle in 1 place, so we would call that a tangent ray. Line AE. This entire line, going on forever, crosses the circle in 2 places, 2 different points, so we call that a secant. In example 1, what's the best word or the best way to describe AG? Line segment AG hits in 2 places, so we would call that a chord. CB. C goes from the center out to the line segment, that would be a radius. In that same example, name a tangent and a tangent segment. Well, the tangent is the entire line, and remember, I could label this line right here, line running through D, B, and E. I can name that with any 2 of those letters. So I could call it line DB, line BE, line DE, whichever way I want to. So we'll say line DE. And a tangent segment. Well, a tangent segment is just a line segment that is tangent. I could say line segment DB, or I could say line segment BE. Either one of those only hits in 1 place. So DB or line segment BE would also be a tangent segment. The words radius and diameter are used for lengths as well as segments. When I say the radius, I'm talking about the length of a radius. Remember, there are a lot of radiuses in a circle, But if I'll ask you for the radius, I'm wanting to know how long one of those is, which would be true of all of them. Likewise, the diameter of a circle is the length of a diameter. Remember, there are several diameters, so if I find the length of one of them, I have found the diameter. So in this one, radius of circle A, going from A out to the center, is 1, 2, 3. The diameter of A then, from one side to the other, notice that a diameter is made up of two radiuses, so it is 6. The radius of segment B, it's 2 spaces out, so it would be 2 units. And the diameter of B, I could go 2 this way and 2 that way, and so it would be 4. Remember, a diameter is equal to 2 radiuses. The radius of C and D. Well, here is center C, and so since that is the center of this circle, we're not talking about the smaller circle, we're talking about the larger one. So the radius is 1, 2, 3 spaces. That would make the diameter 6 spaces. And for D, we got here out to here, so the radius is 2 spaces. That would make the diameter 4 units. Coplanar circles. 2 or more circles in the same plane are said to be coplanar. 2 coplanar circles can intersect in either 1 point, 2 points, or no points at all. Let's look at that. 1 point of intersection we call tangent circles because they meet in exactly 1 point. Coplanar circles that intersect in 1 point are the tangents. Remember, one could be inside the other, or the two could be completely separate except for that 1 point. It can meet in 2 points if they cross over each other, and it could be no points at all. Notice when a circle is inside of another circle, in other words, they have a common center, we call those concentric circles. Common tangents, a line, ray, or segment that's tangent to 2 coplanar circles. Notice we have 2 different examples of common tangents here. One where the tangent goes in between the circles, and the other where the tangent simply runs beside both circles. So how many tangents would this have? Well, if you think about it, I could draw 4 different tangents. I can draw one on the outside over here, one on the outside over here. I have 2 different ones that would go through the center. So we can see we have 4. What about this one? Well, if I think about this one, I'm going to have one out here, one up here, and I could have one through the middle of that. So 3. Those 2 circles are actually tangent, but since they only meet at 1 point, there is a line that goes through that 1 point. And in this one, I would have 2 common tangents. How many common tangents for this? And draw them. So that has 2 common tangents. What about for these? That only has 1 common tangent. Remember, tangent circles will only meet in 1 point, so it makes sense there would be 1 common tangent. And this one, there's no common tangents here. If I were to draw a tangent to the inside circle, that would not be tangent to the outside, it would be secant to the outside circle. Theorem 10.1 says that in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius at the point of tangency. So wherever the point of tangency is, there has to be a radius perpendicular to it for it to actually be a tangent. So in here, is line segment ST tangent to P? Well, the only way I can know that is to know whether or not this is a right angle. And I would figure that out by plugging into Pythagorean theorem. and it comes out to be true, therefore it was a tangent. In this diagram, find the radius r of circle C. Now, notice I've got r in two different places, but I'm still going to use my Pythagorean theorem so that I can make sure this would be a right angle. So that means that the hypotenuse is this 50 plus r, and then one side is 80 and the other side is r. So I plug into Pythagorean theorem, and I've got 50, r plus 50, the quantity squared, is equal to r squared plus 80 squared. So if you remember how to square a binomial, we will square the first term, twice the product of the two terms, so that's going to be r squared plus 100r, and then square the last term, or 2500. And on the other side, I get r squared plus 6400. Well, now I could subtract away r squared on both sides, and I'll go ahead and subtract 2500 from both sides, and I get 100r is equal to 3900. When I divide by 100, r is 39 feet. So the radius of that circle would be 39 feet. Two tangent segments from a common external point are always congruent. So if I start from a point outside of the circle somewhere and draw the two tangent segments that I can draw, one to each side of the circle, then those line segments will always be congruent. So in this case, I see that I have r. If I know that S and T are tangent points, RS is tangent at S and RT is tangent at point T, then I can find that value simply by setting them equal to one another, substituting in, and solving my equation. So how are we going to do this one? What I have to do is I have to look at, if this segment is 3, so is this segment. And so what I have is my hypotenuse is 5, and so I have a 3, 4, 5 triangle. So yes, that is a tangent circle, because remember, a 3, 4, 5 forms a right triangle because that's one of our Pythagorean triples. ST is tangent. Find the value of r here. So what am I going to do? Remember, I want this to be perpendicular, so I'll use Pythagorean theorem. R plus 18 squared is equal to r squared plus 24 squared. And so I can solve that, and I see that r is equal to 7. Remember, to square this one, you're going to do r squared plus 2 times r times 18, so that's going to be 36r plus 18 squared is equal to r squared plus 24 squared, and then you simply solve that equation. You subtract r squared from both sides, and from there it's just working a simple algebraic equation. Find the values of x. Oh, I'm sorry, I wrote right over that problem. Let me get that out of the way. In order to find the value of x, we notice that what we have are two lines emanating from one point, both tangent to the circle because of those right angles. So that means that x squared is equal to 9. And so if x squared is 9, I can take the square root of both sides, and x is positive or negative 3.